Hello, this is Paul, and I am doing the Spotify playlist designer. My name is Paul Pace, and I'm going to be discussing this. This is for ECE674. It's a neural network applications course. So let's go ahead and break it right into this. So first off, what are we doing? We're going to talk about why we're making this, the kind of introduction section. What do we have? What data is out there? What's been done? The structure of the algorithm, my results, and my overall conclusion for the course itself. So why make it? Doesn't this already exist, right? The purpose of Spotify is to bring you the best playlists that you can watch or listen to for you at any given time, right? Well, yes and no. First off, streaming. I have a very specific use case where I'm, using music for streaming, so I kind of had to pre-curate some of the information. The music overall can increase engagement while you're streaming, and it can make the stream overall more pleasurable, both for the streamer and for the viewers. For my personal life, it also helps me focus while I'm working, as well as just something pleasurable to listen to while I'm doing nothing sometimes. So overall, good thing. So the project's overall goal is just to design something that will make playlists for me, right? So I want to be able to make it to where the playlists are enjoyable, which means they need a variety of music, not just essentially the same song over and over again. Maybe connected themes based on the authors, genres, moods, various other attributes, as well as it fits a specific time span without any repeats. Because when you're streaming, for instance, you have a 2-hour stream and you would like it to last at least 2 hours without repeating. So I can set it up for 2 hours, 15 minutes, so I can skip some songs because I'm like, not feeling that vibe, right? Whatever. Keep on going. So what data do we have? So surprisingly, Spotify actually does a ton with data. Now, connecting with Spotify API was a little bit outside of the bounds of the course, and I just did not want to worry about that while working on the system. So I specifically focused on using external tools that already use this data and collect it for me. The specific one I have linked right here that I used, but many of them do the same thing. There are some that actually add more details. So I did add personal preference values after the fact using about 200 songs from my favorites lists. So the unique parameters were the beats per minute, a energy level, danceability, loudness, balance, acousticness, and popularity. Again, all of these come from Spotify, so there is a means that they are calculating these values. I am curious to see how they are, but very likely we will not get those values out. Balance is a weird word, so it is some way how they measure the mood of the song. So, structure of our algorithm. So, I used PyGAD. I'm familiar with it due to other courses I've taken. So I was like, this is a good option. I think it'll be beneficial. And then I added a specialized class that calculates the values for each type of preference. So each of the parameters, I set a preference value, and then I set a variance, and that's used as a multiplier and some other things. And then the other part is if the length is greater than the maximum length. So let's say 2 hours, it gives you 2 hours and 15 minutes, then it will be a negative value. And that negative value will scale with how far off from the original you are. With 198 songs at about 3 minutes apiece, about 200 songs, you had about 600 minutes or round about 10 hours. 10 hours. The further from the preferred time, the longer the negative value. So that's the larger the negative value. So performance improvements were made at the end. So I set a maximum value for each of the preference values, and then once the fitness exceeded that value, it would start this countdown basically of 10 generations, and then it would reset. That way it didn't last for the entire maximum generation set, which was like 10,000 generations, and it would take forever, and you'd have exceedingly long stretches with no improvements, really, which for the use case here, it's not necessary because you're trying to get some variety anyways, so you want there to be more. And what I found was when it was exceeding for a long period of time, although you would get some variance, it wasn't that much. The overall results, this is the fun part. So I was able to create multiple playlists. We're actually about to do a code walkthrough. So before the performance improvements, there was the input time never exceeded. The feature values were kind of tuned towards the values I wanted, the preference values I entered, but it had a several hour runtime. After the performance improvements, the tuning actually improved slightly. I adjusted some calculations, and it completed usually within like 5 to 15 minutes. And then the user could directly input the time frame that they wanted to have. So overall, I found this as a beneficial experience. I have had experience with AI, neural networks, machine learning, but I didn't get this foundational experience, I'll be honest. I think this is a good course for anyone looking forward to it. And I think this was a good application. This is overall just like it's a heavily modified version of the knapsack problem where your limiting feature is space. And so all these preference values and calculating them is really cool. I want to extend the feature set so that you can basically like say type, I want to have, I want to add features like, but not limited to, adding features to just generally make it better. Like being able to enter the preference you want. So this is just a short code walk through that we're going to go through. These are various outputs that I've generated. Some of them are older than others, but we'll scroll all the way up to the top. This is one of the classes I created, which is a preference value, and then this is how it calculates the fitness. So you have the preference total, and then if it goes over the cap value, it just returns the cap value. And it basically just tunes in on the specific value with a infinite slope. And then that variance, I experimented with it with Desmos, and it actually raises kind of the volume. So if you multiply it high enough, it might not even have any real effect. But let's go ahead and run this. So we can go down here, and we're going to go all the way down to the bottom, and we're going to just do run all above. You will get some warnings, and let's make sure that we have the output window selected. I've ran this once before, so it's requesting our hours. We're going to do 0 hours, 30 minutes, and 0 seconds. Again, you could set that to any specific values you want. You could just set it to hours, and then it's going to run. So each generation, it does the fitness calculations over all of the features, and then it also adds in the overall preference score as well. And as you can see, the genetic algorithm just completed. It's been under 2 minutes, so fairly quick. And then it's going to do some other calculations. It's about to prep 2 charts for us. One of them basically gives you almost like a barcode for each of the binary values in the network right here. So like these 2 songs, for some reason, every time just never get added. But if we scroll all the way up to the top, you get like these various generations. It's really cool to see, and I think this is like the highest fitness one as well. So as you can see, like there's a ton of variance, which means there are thousands of routes you can take with this. And then this is the fitness score. As you can see, basically once it reached the top, it did hit there, and you can see that negative score as well. If we can get this to come up, expand image. There we go. So as you can see right here, it does start very far in the negative. It tends to always be around there, and then it goes up like that. That is one thing that I want to help with this, which is something we will do in the future. And if we go down to our latest output, this is our actual song list. So we've got 1, 2, 3, 4, 5, 6, 7, 8 songs, which is pretty typical. I don't know why this is not wanting to drag down, but it does allow us to see the actual fitness score, usually. And if we look at this value here, we've got a lot of 9s, 10s, 6s. The preference score is kind of the highest weighted item in this version. So as far as future work, the things that I would like to do regarding this is I would like to set it up to query actually the Spotify API directly for songs rather than using this preference score and then doing preference based on the playlists themselves. That way it can be calculated in and have like a small database of songs that it's added in with like key values of the song and the artist and the release date. That way you can have that different song, each of the different songs. And that way it can calculate, oh hey, these are the playlists you tend to like. These are the songs from, let's say, the most popular, your Discover Weekly, and maybe I think they have some Discover Daily playlists as well, which is really cool, and I do want to explore this further. But I do hope that you guys have a wonderful rest of y'all's day. This has been both a presentation of my overall project and a short code review. I do hope that y'all have a wonderful rest of your days, though. And without further ado, bye-bye.